Hello everyone, and welcome to the third section of this video course, Data Preprocessing and Preparation for Machine Learning. In the first video of this section, we will take a look at renaming and converting data variables and data type. First, let's begin by understanding why data preprocessing and preparation is important. We have already learned how to collect the data in the previous sections. Since this data is from multiple sources, we need to ensure that the quality of collected data remains consistent throughout. If the data quality degrades due to factors like missing values or biased samples, then the results of the analysis will be faulty. Unstructured data is also difficult to correlate and further analyze. It is therefore necessary to perform data preprocessing and preparation before any kind of data analysis. The first task at hand is to learn how to rename the data variable. This helps writing faster and intuitive code, ultimately leading to efficient programming in R. Keeping precise names for a data variable will also help you keep large projects well organized. For this, we will be using the employees and salaries data from our dataset. Let's examine the column names of these two datasets by using the names function. Next, we will rename columns with a names vector. We will assign a character vector to the name of the dataset for doing so. You can also rename columns with the call names function like so. To make things easier and avoid having to specify column names and row names separately with the call names and row names functions, we can use the dim names function. This will help us list both the column names and row names in one single operation. The first input vector within the list indicates the row names and the second input vector indicates the column name. That wraps up the concept of renaming data variables. Now, we move on to the next topic, converting data type. Data type conversion is an important step during the pre-processing phase. In the R language, we will fail to specify a data type during the import phase. R will automatically assign a type to the imported dataset. But if the data type assigned does not match the actual type, we will encounter difficulties in further data manipulation. To solve this issue, we will learn how to perform a conversion of the data type. Before that, we need to understand the current type of every data attribute. This will be done using the class function, which will help us determine the data selecting attribute. We can also use the str function to examine types of all attributes. The output shows us that both birth date and hire date are in fact a type. A thing to keep in mind is that if we need to calculate a person's age with the birth date attribute, we need to convert it to date format. Thus, we change both birth date and hire date to date format using the s.date function. Now, we will convert both first name and last name into character type. This is done because it is hard to find exactly the same last name and first name from the dataset. Let's examine the dataset using str. You can convert the data type of from date and to date to date type within salaries to help us start off with performing date calculations. We can easily estimate the age of every employee by calculating the number of years between the employee's date of birth and current year. Let's see how some of the built-in date functions in R and the LubriDate package can help us manipulate the date format data. Date type data allows simple arithmetic operations. We can add or subtract days from the date format attribute using this command. To obtain a time difference in days between the employee's hire date and birth date, we will type. This will help us find the age at which each employee started working at that company. Note that the minus operation can only show us the time differences in days. We will have to carry out some more calculations to change the differences in time from days into a different measurement. Let's use the diffTime function to determine time differences in a different unit like weeks. You can also determine the time difference in other units like hours, days, etc. Next, we will move on to the LubriDate package. This will further simplify the process of date computation. Let's install and load the LubriDate package to perform the same. Let's convert date data to POSIX format using the YMD function. The interval function will help us calculate the time span between hire date and birth date. We can also examine the period between the hire date and birth date using the s.period function, which will calculate the period of the time spent. We can also obtain the time difference in a yearly manner using the year function. Retrieve the current date using the now function to calculate the age of the employee. Finally, we can now calculate the age of each employee using interval to return the time interval between the birth date of the employee and the current date. Finally, using the year function will help obtain the actual age of the employee. In this video, we learned all about renaming and converting data variables. We saw how conversion can be made easy using the inbuilt functions of R as well as the LubriDate package.